scientists, how are you doing? So we are going back to that playground problem today. We are going to think about what we have learned so far. We've been talking about the sun shining on the Earth's surface, that it's warming up over time. Let's take a look at that picture of our playground and let's review what we have done so far. So we have talked about how Carver and Woodland Playground are both cold at night because we know that the sun is not shining on the Earth's surface. We know in the morning time that Carver Elementary is still cool, but Woodland Playground is warm. And then as the day goes on in the afternoon, Carver Playground gets warmer, but Woodland Playground gets really hot. And we know that this happens because the longer the sun shines on a surface, the warmer it gets. We're still not quite sure though why Woodland Playground is warming up so much faster than Carver Playground. So that's what we're going to investigate today. Now, some of you have already been giving me your predictions about what is going on in the playground, why Woodland is so much hotter in the afternoon, and why Carver is so much cooler in the morning. I want to look back at this book we looked at in our last couple lessons, which is Getting Warmer in the Sunlight. There was a part that was making me think about our playground. So let's look at that. Remember in the desert that it was too cold in the morning for the lizard, right? Eventually, it said the lizard can come out. Now it walks across the pale sand. The sand is warm. The lizard finds a dark rock. The rock is hot. The dark rock is warmer than the pale sand, even though both surfaces have been heated by the same sunlight all morning. When I read that part, it was making me think about the playgrounds, right? So we have this dark rock that is hotter than this pale sand. The lizard sits on a rock and gets warm in the sunlight. Soon the lizard is warm enough to run and hunt. The lizard hunts for bees that are also out in the warm part of the day. They come out and fly around in the sunlight. The lizard catches lots of bees. The day goes on. Now it is the afternoon, and the sun has been up for many hours. The sunlight has been shining on the rocks and the sand for a long time. The surfaces are even warmer than before. And we know that, right? The longer the sun shines on a surface, the warmer it gets. The dark rocks are getting too hot for the lizard. It runs to the pale sand, which is cooler than the dark rocks. Soon the pale sand also gets too hot. The lizard finds some shade to escape the sunlight. This totally reminds me of Carver and Woodland, right? Let's talk about those words. Let's talk about the words that we saw in this story with the rock. The word pale and the word dark. So here's the word dark. Can you say dark? Dark. So what does dark mean? Dark means it's going to be closer to the color black. And the word pale, you say pale? This is not kind of like pail you carry like a bucket. This is pale, meaning that it's closer to the color white. So you have dark and you have pale. The sand was pale in the story and the rock was dark. Now let's look at Woodland and Carver Playground and let's see if you notice something. I know some of you already noticed it and you've told me about it. Those of you who haven't noticed it yet, let's look at Carver and Woodland Elementary Playground. So thinking about the story we just read and talking about pale versus dark, what do you notice about Carver Playground and Woodland Playground? Look at the surface. What do you notice that's different that relates to the book we just talked about? Their surfaces, right? Look at Carver Playground surface. It is very pale. And look at Woodland Playground surface. It is very dark. So is that the reason why Woodland is getting so hot? It's just like that rock in the desert getting so hot. And Carver Playground, even though it's warming up, it's not getting as hot as that dark surface is? Let's see. Okay, so if we think that it's the color of the playground surface that is making a difference, what can we as scientists do to investigate that? Could we make a model? Yes. So let's create a model that will show us if our prediction is correct, if it's the color of the playground that is making the difference, the color of the playground surface that is making the difference. So what kind of model could we make? What could we do? What could we set up? We could do it just like the other ones, right? Let's get some materials. Okay, so here we are back with our light, right? And the light has been representing the sun. And here we are with our rubber. Now, is this rubber dark or is it pale? It's dark. So this is going to be our dark surface. We have our little rubber sandwich here with our thermometer in the middle and our dark rubber on top. So this could represent the dark surface on Woodland Elementary Playground, but then we need something to represent the light surface, right? Okay, so here we have some white rubber. This would be the pale color. And so we're gonna make a little pale colored rubber sandwich. So we have our thermometer in the middle and then our pale color rubber on top. So now we have our dark surface and our pale surface. And before we turn on our sunlight, it's important that we make sure that both thermometers are the same temperature. Well, luckily today I have my assistant, Caitlin. She's going to help us a little bit. So Caitlin, can you go ahead and read the thermometers? What are they at right now?
So right now they are just about at like 20 and 22 on each one.
So they're at cool or cold? What is the dark surface at?
The darker surface is at cool.
And the pale surface is at cool. They're both the same, aren't they?
Yep.
Right? Okay. So Caitlin's going to go ahead. She's going to cover up the thermometers with the pale surface and the dark surface. She's going to go ahead and turn on our sunlight. You can do it. There we go. All right, so now we have the sunlight shining on both of those surfaces. And so we're going to wait 3 minutes and we're going to see the results. So we went over here and we have our pale sheet right here talking about the surfaces that are pale, and then our sheet with the dark surfaces over here. And so when the light was not shining, they were both cool. Now, Caitlin, go ahead and peel the top off, and let's see what the thermometer reads underneath. So the black surface is now hot. And will you take off the pale surface?
So that's 28 is the darker one.
And that one, ooh, look at that. It's still cool, isn't it? A little bit warmer than it was, but still cool. 2%. All right, let's cover those back up because we're going to let it go even longer now. And let's go ahead and let's record what we saw. So over here on the pale surface, you're going to color that what?
Cool.
Yeah, it was still cool, wasn't it?
Mm-hmm.
That was the shorter time. We've only let it go for 3 minutes. And then over here on the dark surfaces recording sheet, for the shorter amount of time, you are going to color in what?
We are going to color in hot.
Hot, because the dark surface got hot after 3 minutes.
Very fast.
All right, so we're going to come back to you 3 more minutes and see what the results are. Just to show you what Caitlin did, so over here for the shorter amount of time, right here, she went ahead and colored in the cool. She made a little mistake and colored in cool. Just cross that out, no big deal. And then over here for the dark surface, she went ahead and colored in hot. So now, oh my goodness, look at that. The time is up. Okay, our time is up. So Caitlin is going to go ahead and take off the top surfaces, and we're going to see what the temperature is after a long amount of time.
Let's check the black surface first. Ooh.
So that's at very hot,
Very
isn't it?
hot. Yep.
Go ahead and take off the pale color surface.
Ooh.
And look at that.
That
It's
one's
still down at warm. So it got a little bit warmer, didn't it? But not like the dark surface. So go ahead over here and record your observations. Okay, so there are recording sheets for the longer amount of time. For the pale surface, it got too warm. And for the dark colored surface, it got to very hot. And both of the surfaces were under the light for the same amount of time at each interval that we tested. So thinking about our model and how we used it to do our investigation, let's look back at our Handbook of Models book to learn more about what we did. So throughout this whole process, we've been looking at one thing at a time. First, how did the playground warm up? And we had to figure that part out first. Then, why was it getting warmer throughout the day, and investigating that, right? Now looking at the surfaces and the color of them. As a scientist, you have to pick one thing to look at. If you look at all of it at once, it's too confusing. You don't know what the real reason is of what things are going on. So in this part, it's talking about how scientists look at one thing. Even just now, right? We did this investigation and we used dark color rubber and pale color rubber. Well, what if I had used light colored or pale colored foam? That would have been a different material. I had to use the same materials when I was making the model, just different colors, because again, we just are investigating one thing at a time, not lots of things all at once. This says, models help scientists investigate one thing at a time. Get a little bit closer so you can see it here. So often the things scientists want to investigate are very complicated. There are lots of things going on at once. That makes it hard to tell how one thing affects another. When they want to know if just one thing affects another, scientists make models. Models are often simpler than the real thing. In a model, scientists can make a complicated things like weather, simpler. So now we're going to learn about the real water strider, which is this kind of a bug, the model water strider, the model they made of it, real river plants, and model river plants. So here is the water strider model. So scientists made a model of a water strider. Water striders are little bugs that live on ponds. They can stand and jump on top of the water. The scientists asked, how does a water strider jump on the water without sinking? The scientists found out that the water strider's curved legs help it jump on the water without sinking. Why did they need a model to learn about water striders? Water striders are animals with many body parts. Scientists had the idea that the water striders' curved legs help them jump. They needed a simple model to test their idea. So this is the real water strider right here. They made a little label and some leader lines pointing to the different legs they have. The blue part in the picture is the water. So now looking over here, this is the model that they created. It says, how was the model like a real water strider? Well, the model had long curved legs like a real water strider. How was the model different from a real water strider? The model did not have a head or a body, it only had legs. The scientists only wanted to study one thing, right? One thing at a time. They want to study how the water strider uses its legs to jump. So this is the model of the water strider. The gray part in the picture is the water. So by making this model, they're not worrying about any other part of the body except for the legs. All right, let's look at the river plant model. So scientists made a model of plants in a river. The scientists asked, do plants in a river slow down the water? That's what they were wondering. The model plants made the water in the models slow down. This shows that real plants slow down the water in a river. Why did they need a model to learn about rivers? Well, real rivers are complicated. They have flowing water, plants, animals, rocks, boats, trash, and more. The scientists wanted to find out about just the plants and the water. So here are the real river plants underwater. Now let's look at the model. How was the model like a real river? The model had flowing water like a real river. It also had pieces of plastic shaped like plants. The flowing water made the plastic plants move back and forth like the real plants in a river. How was the model different from a real river? The plants in the model were made of plastic. The model did not have rocks, animals, boats, or trash in it. So these are the model river plants, and they were made of white plastic. So as you can see, by using the same kind of material, but having them be different colors, we were just testing one thing at a time, right? We were testing whether sunlight heats up a dark surface faster than a pale surface. Now, this is what we saw with our model, but we know as scientists that we also have to explore it in the outside world too. So our next lesson, we're going to go outside with our thermometers and check out pale surfaces versus dark surfaces. I'll see you then.